Hey guys, tonight we're going to talk about the trig form of a complex number. So, trig form of a complex number. And when they say trig form, that also means polar form. That's what they're really talking about. So that means polar form. So let's talk about a complex number. So a complex number is in the form a plus bi. Okay, so that's a complex number. And if I graph the complex number, we have the real axis, and we have the imaginary axis. And if I had a plus bi, I would just graph it. So it would be over a, and it would be up b, and that point would be the complex number a plus bi. Now, hopefully you recognize this is very similar to the stuff we've been doing in class. So, for example, I can find this angle. Maybe we're going to need that angle. And I can find this length, which we call r. And now I just got to take care of this. Now we've done this. So this a value is called, we did the r cosine theta, right? That's the r cosine theta. And the b value is the r sine theta. So we have a complex number, and we're going to call it, let's call it z. Z is the complex number. So z equals a plus bi. So z is our complex number. And so I can find the value of r. And how we're going to write this is it's the absolute value. And we also use that as magnitude when we did vectors. And in here, we're going to use another word. So this absolute value is called the modulus. And it's exactly the way we've been doing it. We're going to take the square root of a, so it's going to be this, a plus bi. And it's going to be the radical a squared plus b squared. All right, so that's the r value. So the new word is modulus. So you might hear that word. Its absolute value is z, which we call this absolute value z was called the magnitude when we did vectors. Now it's called a modulus. So the trig form of a complex number. So now let's put this in trig form. So we start out with z equals a plus bi. And then we're going to say z equals, a is really r cosine theta, just like we did. And the b is r sine theta. And then we have this I sitting over here. Now when we look at this, we have an r in both spots. So I can factor out the r and cosine theta. And we don't like the I in the back like this, so we'll put the I in the front. So it'll be I sine theta. And so this is our formula. Z equals r parentheses cosine theta plus I sine theta. So let's try a problem with this. All right, so let's try a problem. So let's write down our little formula. So z equals r parentheses cosine theta plus I sine theta. And so let's find the trig form of 1 minus rad 3i. 1 minus rad 3i. This is question number 1. Okay, so what I would do if I were you, and we're going to find it in degree form and in radian form. And we're going to realize we're going to do a lot of radians. So let's just get started. All right, so what I need is, I need the r and I need a theta, just like we did when we were doing regular. So I'm going to make a little sketch. So it's over 1 down rad 3, whatever that is. And so it's 1, and this is rad 3. And I'm going to do Pythagorean theorem, and we're going to find the r value. So that's 1 squared plus rad 3 squared with a big old square root. 1 and 3 is 4. Square root of 4 is 2. This is a 2 by using Pythagorean theorem. So far I have, if we call this z, so now z equals, r is 2, so I got a 2 outside, cosine angle. So I got to find an angle. All right, so let's get the angle here. So this would be the angle. And I'm going to do second tan, just like we did. And it'd be opposite rad 3 over 1. And so you punch that in a calculator. And we're going to do in degree mode. So it's second tan. And type that in, and you get 60 degrees. But now the whole thing is, it's not in the first quadrant. So now I got to drop it in the right quadrant, and hopefully you see it's really 300 degrees. In this, for this problem, the theta is this angle, really called the directed angle. And so it's going to be 300 is our angle for this problem. So 300 degrees. So 60 is really just our reference angle. So this would be 2 cosine 300 plus I sine 300. And these are in degrees. Now, so this is in degree form. And if they say do it in radians, which they would tell you at the beginning of the question, it would say, oh, from 0 to 2 pi or something. Or if they say 0 to 360, you know that's in degrees. Well, I need to convert 300. So if I convert 300 degrees, we multiply by pi over 180. And we reduce this down, and you're going to get pi over, what do we get? 5 pi over 3. And that's how much 300 degrees is. So this would be 2 cosine 5 pi over 3 plus I sine 5 pi over 3. Well, those numbers worked out nice. So let's try another problem. Question 2. It's negative 3 minus 4i, and same question, same type. Convert to trig form. All right, so I need to get an r value and I need an angle. So r and angle, that's what we need. So backwards 3, down 4. Right, this is the real, and this is the I. So that's this. Okay, so I'm going to make my little triangle. And we're going to label 3 and 4. So I'll do a Pythagorean theorem and find the r value. It's actually finding the modulus of this imaginary number, the absolute value of z. So it's 3, 4, and hopefully you recognize the 3, 4, 5 triangle. So I have, for my formula, I already have the r value. So it's 5 parentheses cosine, and now I need an angle. So second tan that, get an angle. So 4/3, and I'm not putting any pluses and minuses in it because I'm going to get a reference angle. And that reference angle, when I punch it in, I get 53.1. And I'm just going to go to 1 decimal place for this. So 53.1. And now I have to drop it in the right quadrant. So I'm going to add 180 to it. And so this becomes 233.1 degrees. So this is cosine 233.1 plus I sine 233.1. Now, if they want radians, okay, which we're going to do both, right? So this is, so z equals, and this is degrees. And now we're going to do it again, radians. All right, so now I got to convert this. So now the trick is, we do pi over 180, but this doesn't work out nice. It doesn't work out nice. So you just type this whole mess in a calculator and just get a number. So try that. And hopefully you get 4.07. And that's in radians. And this would be the exact number. So if we called it 4.1 for this problem, let's call it just 4.1. So it'd be 5 times cosine 4.1 plus I sine 4.1. And that's it. And that's how you convert from complex form into polar form. And that's it. Have a nice night.